Hello, everybody. Today we're going to be talking about quadratic functions and introduction to kind of what roots are. What are roots in a quadratic equation or quadratic function? So I have a couple of problems that we're going to go through, and then you're going to have an assignment based off this. So we've been factoring a lot of quadratic equations and different polynomials, but today we're going to look about not only just factoring it, but what those factors mean and what those factors do, which is make these roots. So as far as roots go, so roots, I'm going to use Desmos as an example here with this equation. So if I put in this equation, we can start factoring it like we have been in some of the past assignments. But what the roots are, well, you can see the roots more visually here on this graph. And on this graph, we have this quadratic, it's called a parabola. And so this parabola comes and it goes through the x-axis at two spots. It comes down underneath it and comes back up. So what I know, or what I've heard as the origin to the word roots, came from if you're looking at this quadratic equation on a graph, this parabola comes down and goes underneath the x-axis, almost as if the x-axis was the ground and it goes underground. It's like the dirt. And in a plant, what comes under the ground? The roots. The roots are under the ground. So what we're looking at are these 2 points here where we have these roots. So as you can see, there's 0 for the y values because we know it's at the x-axis, can't be higher or lower, it has to be at 0. And there's an one root is -2 and one root is -7. So when we factor these equations, we're looking for those two roots and trying to figure out what those roots are. And what those roots end up being are different for every parabola, but they're where the parabola crosses the x-axis. So I'm going to go back to Alex here, and let's look at one of these questions. So this is already factored. We don't have a quadratic equation right now. They've already factored it for us. So we're going to take these two factored binomials and try to find out what the roots are. So I'm going to start. If you notice, they're both equal to 0. And if you remember from the Desmos graph I just showed, it's where the y value is going to be 0, where they cross the x-axis. So if we take our two factors and we set them equal to 0, then we'll find out where they're going to be at 0 on our graph. And there's two different factors, two different groups here, two different parentheses. So they're getting multiplied, 5 plus v and 5v plus 8. Each of these are getting multiplied. So if we're multiplying something to make 0, then something has to be 0. 0 times anything is 0. So if this first term ends up being 0, or the second term ends up being 0, then our answer will be 0. So what we're going to do is we're going to take each of these terms separately and kind of take this problem and divide it into two pieces. And we're going to have 5 plus v. Oh, there we go. And that's going to equal 0. And then we're going to also have 5v plus 8 equals 0. So now we have two different problems here. No matter which one equals 0, the whole solution will make 0. And for most parabolas, since they make that U shape, there's going to be one point where they cross the x-axis. There's only one time where they cross it at one spot, and that's where the vertex, the very tip, touches the x-axis. Most of the time, the x-axis goes through the parabola, and it creates two different points, which will make two different factors, which are why these problems split into two. It's very rare that there's only one. So I'm going to go back to my red problem here, this one. I have 5 plus v equals 0. So I'm just solving for v at this point. So if I have 5 on this side, I'm going to make a 0 pair. I'm going to subtract 5 from both sides. And when I do that, these 5s make a 0 pair and cancel. So now I have v equals 0 minus 5 is -5. So there's one of my factors. Now I'm going to go over to my blue equation and find the factors for this one. I have 5v plus 8, so first zero pair I'll make here is with negative 8 minus 8. Those cancel out. Now I have 5v equals 0 minus 8, which will be negative 8. And now I have 5 times v, so the opposite of multiplying by 5 is dividing by 5. And those will cancel out. So now I have v equals, and since this fraction here doesn't really divide evenly into a whole number, I'll just leave it as a fraction. You could put it as a decimal if you want, but I'd rather keep it as a fraction. So now I have v equals negative 8 over 5 and v equals negative 5. So I'm going to put those as my two answers here, and how I think they want you to write them in, separate them with commas. So how I would write it would be negative 5, comma, negative 8 over 5, like that. So now I'm going to look at a little bit different of a problem. Still kind of the same thing that we want to do here. We have this quadratic equation, and instead of giving us the two factors, they're going to give us a little more steps to do. We have to factor this and then do what we did on the last problem. So if you notice, there's not three terms here. So we can actually kind of take some of these out here. And if I put a parentheses on this, I can factor term out. So both of these have v, and both of them are divisible by 3. So now I'm going to put 3v here, and inside the parentheses, I'll have v plus 7. So now I have this problem, okay? It's a little bit different than the last one. The last one had two groups of parentheses, whereas this one only has one. So now if I'm looking at my answer, for one of my roots, I'm going to have v plus 7 equals 0. And then the other one is going to be 3v equals 0. And I was supposed to make those two different colors. I forgot. Oops. So for this green one, which I'm going to put a little orange on. So this green / orange problem, if you notice, whenever you have something like this, if we're setting it equal to 0, no matter what this number is here, it's going to be divided by with 0. So it's going to be 0 divided by 3, and 0 divided by anything will still be 0. So now we have v equals 0. So that's going to be one of our roots up here is 0, comma, and the other root, let's go back to this completely green problem, and opposite of positive 7 is negative 7. That makes a 0 pair, and then we'll have v equals negative 7. And I'll use pink to cross off my 0 pair there, and in purple, I'll write my answer 0 and negative 7. And those will be my two solutions there. If there is a problem where there's no solution, you can write that. But for most of these, from what I've seen on ALEKS, they're not giving you any with no solution. So now I'm going to go to the next problem. And as these problems go on, some of them are going to be getting longer and longer. The first one, it gave it to us in factored form. So it gave us the two factors, and we had to find the roots from there. This one wasn't factored, but it was in the form ax squared plus bx. So there was no c at all. It was just a and b. Now this next one is going to have the three terms. So it's going to have the a term, the b term, and the c term. So for this one's going to be longer than those last two problems. But we're going to have to do what those last two problems did at the very end and look for those roots. But first, we got to factor it before we try to find the roots. So factoring this is kind of like similar to what we've done before. So if I have P and Q and I'm making my table, I'm going to have to look and say, well, I'm going to have to multiply from A and C term, the first term and the third one, which is 1. There's no coefficient out there. So that's the same as a 1 times 18. So I need to multiply to positive 18. And I need to add to the middle term, the B term, which is negative 9. So now I have this table here with P and Q. And then I have, oh man, that table is gorgeous. And now I have two numbers that multiply to negative 18 or positive 18 and add to negative 9. So let's see, I know that 6 and 3 multiply to negative 8 or positive 18. I keep saying negative, but then they do not add to negative 9. Let me try if they're both negative. I think that will make it work. Positive 18 and negative 9. All right, good. Oh, that check needs a little help. There we go. So now I have my two terms here in the middle. So let's write those out now. Now this becomes V squared. Actually, I don't want to write this over here. Can I erase it? Will it let me? Nope. Sometimes it doesn't. Why? Who knows? All right. So over here, I'm going to write V squared. And now I'm going to have negative 6V minus, oh, that 3 needs a little bit of plastic surgery. And then plus 18. So now I have this term here, and I'm going to use orange, and I'm going to keep factoring it by grouping. Group the left, group the right. So now I have, in this term, I can take out the V's and say this will be V on the outside of the parentheses. And inside, I will have, let's use this light blue. What remains will be V minus 6. Over here, I can take out a 3, but I want that V to be positive. I want it to match this, V minus 6. So if I take out a 3 out of here and take out a 3 out of here, that works, but I want to take out a negative as well. That way it matches. And I have negative 3. This divided by negative 3 will be positive V. This divided by negative 3 will be negative 6. So now I have, in purple, V minus 3 as one term, and V minus 6 as my second term. Now I have my two factors, and what I'm going to do now is set them both equal to 0 to find out my roots. And as you get going on this, it'll get a little bit faster for you. I already know the roots are going to be positive 3 and positive 6. Okay? And I can see that from here without writing down the next steps, because V minus 3 equals 0 will be the first one. And I know the opposite of that negative 3 will be plus 3. And I'll have V equals 3. And I'm going to do the same for that V minus 6. I'm going to spare you some time and I'll pause it. So with both these, I make that 0 pair, and I'll get the opposite of what I started with. So when I saw it here, I knew the opposite when I did my 0 pair would be positive 3, and the opposite would be positive 6. So I already knew just from looking at it here that it's going to be 3 and 6 as my answers. And so my roots are going to be, oh, there it goes, 3 comma 6 as my answer. And as you go, sometimes it won't be V minus 3, it'll be 5V minus 3. And you might have to do an extra step. But these two terms at the end, most of the time will just be a single step single step equation that you need to solve to find the roots. And later, as we get into more and more, it won't be single step equations, they'll be more complicated. But at this step in our process, there are going to be some smaller equations to solve. So I'm going to go through another one. This one's going to be a little bit different. And if you notice that first term is a coefficient greater than 1, that a term, that's a 5 now. Last one, it was just a 1, but now we have a 5. So I'm going to do pretty much the same problem again, but you'll see it might get a little more complicated towards the end, especially with those last two factors. So I'm going to make my table again, and I'll pause it to save you guys some time. All right, so I have my table set up, and I need these two terms to multiply. Now, if you look at this, sometimes they do this, which I don't know why. It just adds an extra small step. It's nothing major, but they do it to you just to annoy you, maybe? I don't know. It annoys me. So if you notice, it's not set equal to 0. We have this -4 here, okay, on that side. So we need to bring the -4 to the other side and cancel it out so it's just 0 on that side. So if I add 4 underneath there and add 4 on this side, well, 4 is not a like term with any of these ones. These ones all have u's. So what's going to end up happening is it's just going to be 5u squared plus 21u plus 4. All these u's and 4's will probably not get confusing, right? No, it'll be fine. Good thing my penmanship is perfect. So now we have this term here. Okay, we have 4. Okay, we have 5u squared plus 21u plus 4 equals 0. And now on our table, the two terms that we want to multiply together are these first and last, the a and b. So 5 times 4 is 20. And the middle term is 21. Oh gosh, that's a funky looking 2 right there. And those are both positive. And now I'm going to fill out the inside of this table here. So if I have p times q, I need to multiply to 20, add to 21. Well, I know that 1 and 20 multiply to 20, and 20 plus 1 makes 21. That checks off. They're all positive, so I don't need to worry about negative signs there. That makes things nice. And so now I'm going to have 5u. I'm going to try to go slow and take my time writing this out, so I'll pause. All right, so I've rewritten out my equation here. 5u squared, the plus 4, and now my two middle terms are 1u and 20u. So from here, I'm going to group them together, and I'm going to use this light blue. Group these together, and let's see, out of this one, what can I take? I can take out, looks like the only thing they really have in common is the u. So the u will come out, and that'll be on the outside. Over here, what can I take out? Well, they have a 4 in common, so I'll take out a 4, and specifically a positive 4. And so now I have positive 4 here, and on the inside, orange, if I took those out, I'll have 5u plus 1. And over here, if I take out a 4, it'll be 5u plus 1. All right, so the oranges match, which is good. And now I'll rewrite the whole thing in green. It'll be u plus 4. And this will be 5u plus 1. Now I have my two terms, and they are both going to equal 0. And actually, I should have put an equal 0 up here too. Don't want to leave that out. Should have plus 0 on the side there for all of those. So if I have u plus 4 and 5u plus 1, these are my two factors, and I'll have to check for the roots for each of these. And if you notice, last time it was just the variable plus a number, the variable minus a number, and I knew to switch the signs and they'd be fine because whatever made the 0 pair would be the answer for our root. But on this side, there's a little bit more to do. So this one, I'm not going to do any more work. I already know that my answer is going to be -4 for one of the roots. And in this one, it's going to be 5u plus 1. So now I'm going to take that one and do that one over here on the side. and 5u plus 1. If this one equals 0, I'll have to do minus 1, 5u equals negative 1. Then I'll have to divide both sides by 5. And u equals negative 1/5. And I can write that up here in purple as well, negative 1/5. And because I was lazy and didn't do it as I was writing it, I'm going to go cross out those zero pairs and stuff. So now my two roots for this one are going to be negative 4 and negative 1/5. And if I try to graph this, let me see if I can copy and paste it. Nope. All right. 5u squared plus 21u plus 4. I wrote that down. I'm going to close out this. I'm going to go to Desmos. And if I type this in, 5u squared plus 21u plus 4 equals 0. Actually, I should just make it equal to y. Okay, equaling y did not work. I needed to put f of u. That way it knew that my variable was u. I think if I used x's the whole time, it would have been fine. But if I go to my graph here, you'll see I have these two different ones. I said negative 4 was one of the solutions, and the other one was negative 1/5. Well, 1 divided by 5 is 0.2. So I got my two roots here, and this is what my parabola would look like. Okay, and this is how and where these roots would come on this problem. So there's one more problem I want to do, and on this one, it's a little bit different because it's kind of going the opposite direction to the ones we've been doing in this video. So this is a problem where they give you the two roots and the leading coefficient. So just like in this problem, it's probably going to give us different numbers when I look at it now, but we had a leading coefficient that was 4, or in the last problem 5. Or if I go to this one says leading coefficient is 1. So it's going to have no number in here, which means the same as a 1. So they're going to give us that number, whatever number's in front there of the highest term, which now the leading coefficient is 3, and our roots are these two. So what we're going to have to try to do is go backwards in this problem. And instead of factoring, we're going to want to be multiplying after we figure out what our factors are. So at the end of the problem, we always end up with our variable equals negative 6. And, I want to make this a different color. Don't mention that little red X. And this is positive 4. All right, so we're going to leave that 3 alone for just right now. We're going to look at our two roots. So we would say our two roots are negative 6 and positive 4. That's what we write up here. Well, if we go backwards in these problems, I want to set this equal to 0. So just like we did on these last terms, I'm going to be subtracting them, do the opposite so that I have a 0 pair. So this 0 pair gets canceled. And now I have x minus 4. These aren't like terms, so I just write them as x minus 4 equals 0, which is kind of like a step behind what we were doing on the last problem. We're just going kind of backwards through these steps. So now I have a factor of x minus 4. And if I go to my red problem, I'll do the same thing. Plus 6 on both sides. If I can make a 6. Beautiful. And this will give me x plus 6. Those canceled out to make a 0. So now my two factors are these two that I set equal to 0. So I can write it as x plus 6 and x minus 4. So now I have these two factors, and I want to make the entire equation. I don't want to have it left in factored form. I want to write the whole thing, which means they're going to want us to make a apartment and multiply this out. Oh, I made my apartment kind of small. Hopefully I can write really neatly and show all these numbers. Since I haven't had any problems with that before, it should be easy. All right, x plus 6, and this one is x minus 4. Remember, when you do this, there's no specific order or which ones you have to put. I could have put the x minus 4 on top and the x plus 6 on the side. It doesn't matter either way. So on the inside here, let's go x times x is x squared. 6 times x will be 6x. X times negative 4 will be negative 4x. Connect that. And negative 4 times 6 will be negative 24. And so now what we'll do is I'm going to write this all the way out. X squared minus 4x plus 6x. Oops. 6. There was always a 6. Always a beautiful 6. Beautiful. And x minus 24. Why does it not let me erase things sometimes? I don't know. Especially because I need to erase things at different times. So I have these two terms in the middle here that I want to combine. And now I have x squared, negative 4x, positive 6x. That leaves us with a combined total of positive 2x minus 24. And that is almost our final answer because we still have this coefficient 3. What are we doing with this coefficient 3? Okay, pretty much what we can do here is add that 3 in from the whole time. It's always kind of just off on the side there. So I'm going to use a color I haven't really used yet. I don't recognize any color I haven't used yet. Dang it. I'm just going to use this light kind of blue, even though I used it for the table. So this 3 is kind of like it's always been there. I have 3 over here. I could have said that these two terms are multiplied by 3. So really there's a 3 out here, and these are inside parentheses. And there's a 3 over here inside the parentheses. So when you're multiplying, there is no order that you have to choose when you're multiplying. It's the same operation. You can do it in any order. Just like when you do PEMDAS, you can do it in a specific order, but when you get to the letter M for multiplication, you can do all the multiplication you want in whatever order. But if you do addition and multiplication, there's a certain order you do them in. So you have to really make sure. You can't do the parentheses multiplication in any order, but if it's just lots of multiplication, you don't have to worry about the order. So I could have multiplied a 3 into this term here, into this binomial, and then multiplied them all together here. Or I can kind of do what I did here. Left the 3 out the side, multiplied these two all together, and left the 3 at the end. Could have multiplied with this, and then multiplied. It doesn't matter the order. So what I'm going to do here is now have my final answer, and I guess I'll put it in red. This 3 is going to get factored in. The distribution will go into each of these terms, and now it'll be 3x squared. And our leading coefficient was supposed to be 3 at the end, so that works out. 3 times 2x will be 6x. And 3 times negative 24, 72. I think so. I'm going to pause it and double check it. Why did I write it down before I double check it? I can't erase. Oh, gosh. Double checked it. Thank goodness I got it right, because I would have to just scribble on top of it. It wouldn't have worked. Maybe put white out on my computer. The district might get mad if I do that. Anyway, this is going to be our final answer, and this should be our total factored out. And if I look at the explanation, what do we have down here at the end? 3x squared plus 6x minus 72. So for this problem and for the others, this one is kind of going backwards, but for these other ones, we're looking for those roots. Okay, so we will have to do some of the factoring skills like we have, but I'm going to give you only a couple of those. I want to give you guys more of these ones that have the factored form already, so you guys can practice really searching for the roots. Then I'll have you do a couple where you have to do the whole problem together. Thanks, guys.